Hello everybody, this is Chris with Overclockers Club. I've got something cool from Fractal Design. Well, you might look at this and say, wait a minute, Fractal Design already has an Ion+ 860 watt platinum power supply. But wait, actually this is the Ion+2 Platinum 860 watt power supply. So, one of the things I'll be doing is trying to figure out what the difference is between the Ion+ and the Ion+2. First, we'll scan over the box and see if there's anything interesting on it. And really all of the information about this is pretty much right here on the back panel. So it's an 80+ platinum, 10-year warranty, semi-passive 0 RPM mode. That just means that the fan can be put into a mode where it's off when there's a light load or no load. And that's a nice function. When you put it in that mode, the unit is just extra quiet. Of course, the 660 watt Ion+ Platinum power supply that I reviewed earlier had that functionality, and it was nice. But even when the fan was running, when I had a load on it, it was pretty quiet. So I don't know that fan noise on this power supply is really going to be much of a concern. Looking at the other specs, again, it's 80+ platinum. You've got this ATX 2.52. That might be different from the previous version. The rest of this is all pretty standard. 140 millimeter fan, again, 10-year warranty. Standard dimensions there, 150 by 150 by 86 millimeters. And then again, this is all the same information that's on the current 860 watt unit. As far as your 12 volt rail, you've got 71.6 amps. And then I'll take a quick look at all of the connectors that are supplied. And now I'll get the box flipped over here and we'll take a look at what's inside. And the box is open. First thing I see here is your power cord, 16 gauge, hot, neutral, and ground in there with some nice thick insulation. Here's the user guide with some tie wraps there to help with cable management. And it does come with some mounting screws for the power supply. And the user guide, you might think, boy, I've built a lot of systems and I really don't need to go through that. But it's still interesting to take a run through it. Now, this is in several languages. But what's interesting, to me at least, is the little chart there, a little graph that shows your fan noise based on RPMs and then the efficiency. And a quick note on the efficiency. Actually, I just realized this is, oh, I see. This user guide covers multiple power supply capacities. So this is the 860, so we've got a 560, the 660, and 760. Last one here is the 860. Okay, I was looking at the wrong chart at first. Okay, so the way the efficiency works, you might think that bigger is better. So if you calculate that your system uses, say, 650 watts, well, I'm going to go ahead and spend the extra money on a 1,000 watt power supply. And you can do that. The 1,000 watt power supply will work just fine. But if the maximum that your system uses, like I said, let's just say it's 500 watts, well, the maximum efficiency is at 50% load. So let's just say you've got a 1,000 watt power supply. I know I said 650 is what your system would use, but let's just say your system uses 500 watts. You've got a 1,000 watt power supply. That would be a decent choice because at 50% load, if the maximum wattage that your system uses is 500 watts, then you're going to get the maximum efficiency on a 1,000 watt power supply. But you really need to watch what your system actually uses and determine that. But what's interesting here is the curve. Look at how that's straight all the way back here into the 20% range. That's unusual because usually you see, like the bottom curve here, if we look at some of these other power supplies, typically you see a curve more like this where your maximum efficiency happens right here at the peak of the curve, and that's usually around the 50% mark. But this is interesting. On the 860 watt power supply, we have a straight line. So even at 20, 30, 40, 50%, your efficiency is the same. So that is really interesting. And then it starts to drop off. Again, we're only talking from 92, a little over 92 maybe, down into the 90 range, 89. So that's not a huge dip if your power supply is a little oversized, but just something to consider when you're choosing or sizing a power supply. And there are some nice online tools to help you choose a power supply based on all your components. So, you input the processor you're using, whether you're overclocking or not, your graphics card or the number of graphics cards, the number of hard drives, the number of fans. All of those things come together to determine how many watts that you ideally need. And that helps you pick the right power supply. So anyway, back to the manual. So for this particular one, again, the 860 watt unit, this is nice because it shows you each one of your cables and the length of each cable. So if you need that information, it's right here in the manual, or actually the user guide. All right, so now we can start taking a look at some of the details. What's this? This is what to do if the product is faulty, which pretty unlikely. All right, so I got the camera on the tripod so it's not so bumpy with me holding it by hand. All right, so here's the goodie bag that has all of the cables in it, and the actual power supply is right here. They do a nice job packing it in this closed cell foam, so in case it gets knocked around in shipping, it's well protected. Okay, so here, oh, that's nice. Look at that. Thank you for choosing Fractal Design. Can't miss that when you're opening it. And there it is. Now that is a nice looking power supply, if I do say so. 140 millimeter fan. Here's the back where all the action happens. Here's the little on-off switch for the 0 RPM. So when you have it off, then the fan will just run all the time. And when you turn that on, then the fan only runs when the unit is under a heavy load or enough heat builds up and the fan has to cycle to help keep the unit cool. So they do have printed on there what cables go to what socket, which is nice. And then on the opposite side, it's printed on here, again, basically your power specifications for each one of your rails. Now I have two power supplies here. This is the new one. This is the Ion+2 860 watt Platinum. And this is the one I reviewed previously. This is the 660 watt version of the Ion. And to look at the two, they are indeed very, very similar. The socket layout and count, they're both the same. They both have the little passive fan switch there. And really, I took these and weighed them just to see. I thought the 860 watt felt like it might have been a little heavier, but when I weighed them, they're actually within about an ounce of each other. So not that that really matters. Sometimes on a larger power supply, you get into the 1,000 watt range. Sometimes the cases are a little bigger, and of course they'll be a little heavier. But anyway, all right, so that's the 860. I'll go through the cable accompaniment now. And digging through all of the cables here, first thing to point out is they're using their UltraFlex DC wiring, and this is really flexible. This stuff bends so easy, and that just makes all of your cable routing so much easier too, because you don't have the stiff cables to deal with. Okay, so the first one, this is the main one here. This is your 24-pin cable that goes from your power supply directly to the motherboard, so there's no getting by without that one. So that is one that you'll definitely be using. So let me sort of sort through these. There are some Sata cables, and we have some Molex, and I'm a little surprised that they include that. I guess that's nice. You don't see too many systems now that use Molex cables. These were the standard many years ago, but I guess it is nice to have one. You never know when you've got that one component that uses Molex. And it has 4 Molex connector, so you can hook up. No, not Alexa. I said Molex. No, we're good. Thank you. Okay, so that's the Molex cable. The Sata cables, we've got 3 of those, and I've got 4 Sata connections on this cable. There are 2 Sata connections on that cable, and then there are 4 here. So you have 4, 4, and 2 for a total of 10. So you can hook up 10 Sata devices or Sata connections there. So for a graphics card, we've got 2 of these 6+2 connectors, so you can hook up a graphics card there. And we've got a second one, so we've got 2 of those cables. And actually we've got 3 of those cables. I thought we only had 2, we have 3. And here's your CPU connection. So this goes to the power supply, this end goes to your motherboard, and depending upon your motherboard and the CPU, you may only need 1 of these, but it has 2 of the 4, so you can connect that to an 8 pin connector. And here's another one. This one also has CPU printed on it, and this is an 8 pin, and it does not break down into 2 4s. It is one solid 8 pin. And again, depending upon your motherboard and CPU, as for which ones of these you'll use, you'll just have to check on your system. All right, so now what I'll do is get this hooked up to my test system over here, which is off to the side. And what I like to do is put as much of a load on it as I can. I just got this new 3070 Ti from NVIDIA, so I'll put the load on that. I might even add another graphics card in there to sort of maximize the load on the system. And then we'll just sort of look at the thermals and see how that performs. You know, typically when these things are tested in a laboratory, there's some pretty expensive equipment that is used to put the load on these and really measure the output. Now, one of the things I pay attention to is the quality of the injection molding on the plugs and the sockets. Now, most people, when you plug stuff in, it pretty much stays plugged in. You're not plugging and unplugging things left and right on a power supply typically. You know, you might add another connector, another cable at some point, but usually once stuff is plugged in, it pretty much stays. So what I do is I just sort of feel how positively it pushes in. Do I have to use excessive force? And then to remove it, again, does it take a lot of force? And these are nice and snug, and I don't feel anything out of the ordinary though. They are new, so they will be a little snug. That's the only thing I would say that I notice, but that's good. So I don't have any problems with that. So now we'll go ahead and get all of these things plugged in the proper location. Now typically I use my power supply, I stick it underneath my little test bench here, but today I may leave it out here. It's going to be a lot easier to see the fan and sort of talk about what's going on. And let me get the rest of these hooked up. Everything is connected. I've got my 3070 Ti along with an older but still somewhat power hungry GTX 770. Again, this is just to sort of put as much of a load on the power supply as I can. And we'll hit the power button, and everything is firing up, so that's good. The fan is sort of spinning. Let's see. Oh, I have the 0 RPM mode on, so let's see if I turn it off. Yeah, the fan should run all the time regardless of the load. So the next thing to do is to fire up my AIDA64 software and do some stress testing, which will put a load on the CPU and the graphics cards to sort of put as much of a load on the power supply as I can. So let me get that rolling. And here's a quick example of the 0 RPM mode. So right now the 0 RPM mode switch is on. You can see when I turn it off, that basically means that the fan just runs all the time. But when I put the 0 RPM mode on, that means when the load is very low, like it is at idle, and there's not much going on with your system. Come down here and look at my UPS so you can see the system at idle is drawing 100, 120 watts, somewhere in that range. Now I've got a couple other things plugged into this UPS other than my main system. I've got an Ethernet switch and a router, but they don't really draw that much current. So what I'll do now is let me put my ADA stress test on. So I'll stress test both graphics cards, CPU, and the memory, and we'll look at the load down there on my UPS. But watch the fan here. As soon as I click the mode or the stress test, you can see the system goes under the maximum load, and we're right around 650 watts. I know this isn't the most accurate way to measure it, but this is probably reasonably close. And then when I come up here and stop the stress test, we should see everything drop back down to a more of an idle state. Let's see, we should go down. Yeah. So that just shows you how the 0 RPM mode works. And I'll also point out the fan noise you heard a moment ago when I had the system stressed. That was coming from these fans here, as well as this little auxiliary fan I just have sitting on top to blow a little air across the motherboard. And then both the graphics cards also spool up. So this fan here, even when it's running at full speed, is very quiet. You have to put your head very close to it to really hear it. So when this is installed in a case, fan noise really won't be a concern, at least not coming from the power supply. And for anyone who is curious as to what's inside, I took the top off of mine. Really, you should never have a reason to ever take the top off of yours or open your power supply. One, you'll void your warranty. Two, there are a lot of nasty voltages in there, and if you don't know what you're doing, and in some cases when you do know what you're doing, you can get into a lot of trouble. So generally, do not ever open your power supply. So what I noticed though is on the circuit board, the PCB, you can see, if I can get the glare away, the name Fractal is on there. So that tells me either Fractal manufactures this themselves, or they had a lot of input into the design. So I'll see if I can get an answer on that. The fan here, for anyone who wants to know, it is, get the model number there, it looks like Dynamic X2 GP14 FDB, 140 millimeter, maximum speed 2000 RPMs, DC 3 to 12 volts, and it pulls 0.4 amps. So you can see there's a healthy array of capacitors. You've got your voltage regulators, rectifier, all that good stuff in there. Generous amount of heat sinks to help dissipate the heat. That's what this is over here too, a heat sink. So that's what the inside looks like. All right, so earlier I mentioned that I was going to try and find out what the difference was between the Ion+2 and the previous generation, which was just the Ion+. So I contacted the manufacturer and got a little more information. So the differences are basically, we've got tighter startup timings and transient load response that follow the stricter ATX 12V 2.52 requirements. And if you want to dig into the details on that spec, you can look up ATX 12V 2.52 and read all about it. Next, we've got increased 5 VSB efficiency, which minimizes vampire power drain. We've got more responsive overcurrent protection with 130% trigger point as opposed to the previous 145% nominal on the previous generation, the Ion+. We've got lower initial current draw on the 230 volt system. Of course, I'm using this in a 120 volt application. Now on the 560 watt and 660 watt versions of the Ion+2 Plus, they include an additional EPS cable, which makes sure that really all versions are now capable of powering the latest high performance motherboards, which require a second 8-pin connector. So you need that extra connector and you've got that now. Plus, we have longer SATA and peripheral cables. So what that means is we got an extra 30 millimeters here between your connectors. So that gives you more spacing. You can, move these around a little more. So those are the main differences there between the previous Ion+ and the new Ion+2. Now, a couple of things that I mentioned there, the Vampire Power and the 5 VSB. What that means is 5 VSB is your standby voltage. So that means even when your system is off, as long as it's plugged in, there's still power being supplied by the power supply, 5 volts, that goes to basically power up your power switch. So when you go over to your computer and you press the power button, there's power going to it, and that enables or allows the power supply to then turn on power and supply power to the rest of your system. So the lower the amount of energy that a system uses in standby mode, the more efficient it is. So they've basically tightened that up a little so it's not using as much power. So Vampire Power is just power that's sort of wasted by virtue of the unit still being on, even though it's not technically running. And pricing right now, the MSRP for this one, the 860 watt version, is $149, $149.99 to be more precise. The 760 watt version will be $139.99, so $10 cheaper for 100 watts less. Then we go down to the 660, which is $124.99, so 125 bucks. And then the 560 watt version will be $109.99. And if you look around and compare power supplies, dollar per watt, this is right there with with everyone else in the same range. And I've had decent luck. I've been using my other 660 watt Ion+ for over a year now. No issues with it. It's still quiet, as is this one. Certainly gets the job done. And it's sort of in that sweet spot for most systems between probably the 660 and the 860. Any one of those three would probably be more than enough for most builds. So I would give this the Overclockers Club Gold Award. And that wraps up this review for the Fractal Ion+2 Platinum 860. This is Chris with Overclockers Club. Thanks for watching, and don't forget to subscribe.